Welcome to the Chapter 14 review video. We're going to skip the first page because that's all stuff you can look at in your notes, and we are starting with number 1 with proving each identity. So remember that on problems where we're proving, our goal is to get each side to be identical. And we can either work on both sides or we can just work on one side. It does not matter. The key thing here is that at the very end, both sides need to be exactly the same. So I broke it up into two parts here, and I'm going to go ahead and start with the left side on this problem. So I know that cosecant is the same as 1 over sine, and cotangent is cosine over sine. When I multiply these together, I get cosine over sine squared. At this point, I could change the right side, and I actually could make that into cosine over sine squared, but I'm just going to keep working with the left side of the equation. I know cosine is the same thing as 1 over secant, and I know that sine squared is equal to 1 over cosecant squared. So instead of writing 1 over secant divided by 1 over cosecant squared, I can just make this cosecant squared over secant. At this point, our two sides of the equation are exactly the same, so we know that we are done. Moving on to number 2, I think that the left side of the equation looks like it would be the toughest, and it looks the most complicated, so I'm going to try and simplify that side. Since we're adding two fractions, I'm thinking that we need to get an LCD. My LCD here is going to be 1 minus sine times 1 plus sine, so I'm multiplying the first fraction by 1 minus sine and the second fraction by 1 plus sine. When I combine this, I get 1 minus sine plus 1 plus sine over 1 minus sine squared. I got 1 minus sine squared by foiling those two denominators together. And at this point, we can tell that these signs are going to cancel out, and I have a 2. We also know that 1 minus sine squared looks like our Pythagorean identity. It looks like sine squared plus cosine squared equals 1. So I can make that cosine squared equals 1 minus sine squared. At this point, I know that 1 over cosine squared is equal to secant squared. So I can write 2 over cosine squared as 2 secant squared. At this point, both sides of the equation are exactly the same. If we look at number 3, this looks like one that is pretty complicated on both sides. So I'm going to start with the left and then see if we need to work on the right as well. So the first thing I'm going to do is change tan and cotangent in terms of sine and cosine. At this point, in order to add those, we are going to need a common denominator. So I'm going to multiply by sine over sine and by cosine over cosine. We know that sine squared plus cosine squared is equal to 1. And I can split this up, and I know that 1 over sine is equal to secant, and I know that 1 over sine is equal to cosecant, and 1 over cosine is equal to secant. So I end up getting cosecant secant equals secant cosecant, which is true. So this next section tells us we need to write equivalent expressions in simplest form using only the sine and cosine functions. So if we look at number 4, I'm going to leave cosine squared all by itself because it's already in terms of sine and cosine, and I'm going to change tan squared into sine squared over cosine squared. The reason why I did not think to use a Pythagorean identity here is because I just have a monomial. Normally when we're dealing with Pythagorean identities, we're dealing with a binomial. So as soon as I change tan into sine over cosine, I notice that we have some terms that we can cancel out. So I'm going to cancel out the cosine squareds, and our final answer here is just sine squared. I know this can be my answer because it is in terms of sine or cosine. Looking at number 5, there are a few different ways we could go about doing this. Some of you might divide everything in the numerator by tan squared, but what I'm going to do is I'm going to focus on this 1 plus tan squared, and I know that that fits one of our Pythagorean identities. So 1 plus tan squared is equal to secant squared. Now, I know this cannot be my final answer because it's not in terms of sine and cosine. So now I'm going to have to rewrite secant squared and rewrite tan squared in terms of sine and cosine. So I have 1 over cosine squared divided by sine squared over cosine squared. I know that when I'm dividing by a fraction, it's like I'm multiplying by the reciprocal. So I have 1 over cosine squared times cosine squared over sine squared. I can see that these cosine squareds are going to cancel, and I'm left with 1 over sine squared. Now, since the directions tell us to leave it in terms of sine and cosine, that would be our final answer. Number 6 is another problem that we could do in a bunch of different ways. We could either distribute the cotangent squared, or we could simplify what is inside the parentheses first. I think I'm actually going to go ahead and distribute. And I also changed everything in terms of sine and cosine. So I know that cotangent squared is like cosine squared over sine squared. I know secant is 1 over cosine. So looking at this, I can go ahead, and I know those are going to cancel out, so I'm left with cosine over sine squared minus cosine cubed over sine squared. And this is looking kind of strange, and the one thing I notice in our numerator is that I do have a cosine in both of those terms. So I went ahead and factored out a cosine of each of these terms, so I was left with 1 minus cosine squared. Now, the interesting thing here is we know 1 minus cosine squared is the same thing as sine squared, so I can actually just go ahead and cancel those two things out, and our answer is just cosine. This next section of the review worksheet has slightly different directions. Now we need to go ahead and make sure that our answers are just a single term and or constant. So that means I shouldn't have fractions in my answers. So looking at number 7, the first thing I'm going to do is change everything in terms of sine and cosine. So I have 1 over cosine times 1 over sine minus cosine over sine. I know that I'm going to need a common denominator, so I'm going to multiply that second term by cosine over cosine. So I have 1 minus cosine squared divided by sine cosine. I know 1 minus cosine squared fits our Pythagorean identity, so I can replace it with sine squared. At this point, I notice that my squared and my sine cancel each other out. I'm left with sine over cosine, which if I want to write as a single term, would just be tangent. Looking at number 8, we know we also need to get a common denominator. Our common denominator here would be 1 plus cosine times 1 minus cosine. So after I multiply and distribute, I get tan plus tan cosine minus tan plus tan cosine. I think the toughest thing to remember here is that you're actually distributing a negative tan. So those tans cancel out, and I'm left with 2 tan cosine over sine squared. I got sine squared because of our Pythagorean identity. I know this can't be my final answer, so I'm going to go ahead and change tangent as sine over cosine times cosine, and I notice that some stuff cancels out here. So now I can go ahead and cross out those cosines, and I'm left with 2 sine over sine squared. Now I know I can cancel out the sine and the squared, so I have 2 over sine, which is 2 cosecant. Remember that on this portion of the test, you will have all the identities with you, so you just need to know how to use them. Looking at number 9, I think Pythagorean theorems or our Pythagorean identities are definitely going to be utilized here. I wrote out 1 plus tan squared equals secant squared because that looks similar to this one. In fact, if I subtracted tan squared from both sides, I would just get 1 over, I know 1 minus sine squared is cosine squared. All of a sudden this problem doesn't seem very difficult because I can simplify 1 over cosine squared into secant squared, and that would be our final answer. The next portion of the test here is dealing with double angles, so it's really important we pay attention to the directions. So this is saying that we need to find sine of the double angle. So regardless of what they give us here, I know I need to use the formula for sine. So I already know, obviously, the 2, and I also know the sine value, but I don't know what cosine is. So in order to find cosine, I am going to have to draw out a triangle. Sine gives us the opposite value and the hypotenuse, so I can use that to find that the adjacent side is 3 by doing Pythagorean theorem. So now I know that the cosine value is 3/5. At this point, I can just multiply straight across, and I end up getting 24/25 as our answer. Okay, for number 11, even though it says cosine, we know the directions tell us to find sine of the double angle. So when I look at the formula, this time the one thing I don't know is the sine. So once again, we are going to have to go ahead and draw out a triangle. So if we look at this, I went ahead and used Pythagorean theorem, and I got that b squared was equal to 8, so b is 2 radical 2. But if we're looking at our actual triangle, I know I should write negative 2 radical 2 because this side is going down. So now I can fill in that the sine is negative 2 radical 2 over 3. I'm glad we're going through one with a radical because this can look scary when we're trying to multiply. But all I need to do is just multiply straight across, so I get negative 4 radical 2 over 9, and that's our final answer. This next set of problems, the directions are a little bit different. They're asking us to find cosine of the double angle. And we know 3 different formulas for cosine of the double angle, and I'm going to write all them out right now. So I wrote all 3 of them out, and remember, just like we saw in class, all 3 of them will give us the same answer. I think this first one is the easiest one to use mathematically. However, if I'm looking to save some time, for example, number 12, they give us cosine, so if I use the second formula, that's going to save me time because I do not need to draw out the triangle. So that's the formula that I'm going to use. So I have 2 times 12 over 13 squared minus 1. So I squared 12 over 13, and now I'm going to multiply those fractions together. So I have 288 over 169 minus, I made 1 into 169 over 169 so that we had a common denominator. Now I can just go ahead and keep my denominator the same and then subtract the numerators together. So I end up getting 119 over 169, and that is our final answer. For this second problem here, I'm going to go ahead and use a different formula because this time they're giving us sine. So I'm going to use the formula that only has sine in it. So I'm using 1 minus 2 sine squared. So I'm substituting in our value for sine, and now I'm going to square that fraction. So when I square it, I get 4/13, and now I'm going to multiply those fractions together. So I have 8 over 13, and I decided to make 1 into 13 over 13 so that we had a common denominator. Now I can just do 13 minus 8, which is 5, and 5 over 13 is our final answer. So for this next section, we can either use the half angle formulas or we can use sum and difference. So I'm going to do number 14 using both of those methods. There are 3 different tangent half angle formulas that we can use, but I'm going to choose to use the 1 minus cosine over sine. So the first thing I need to do is figure out how can I write 105 as something over 2. And I can write it as 210 over 2, and I did that by multiplying by 2 over 2. So I have 1 minus cosine of 210 divided by sine of 210. A lot of you may have these values memorized. I'm going to go ahead and draw out a triangle, though, just to make sure that we all understand where I'm going to get these numbers from. So 210 is in quadrant 3, and it's 30 degrees past the x-axis. So this is 30, which makes us negative 1, negative radical 3, and 2. So I get 1 minus negative radical 3 over 2 divided by negative 1/2. We know that dividing by a fraction is like multiplying by the reciprocal. So I'm just going to multiply both of these terms by negative 2. So 1 times negative 2 is negative 2. Radical 3 over 2 times negative 2 is negative radical 3. So this is our final answer. Another way we could have done this problem is by using sum and difference. So I decided to use 45 plus 60 because that adds up to be 105. And I know our formula is tan, 1 tan. My sign in my numerator is the same. My sign in the denominator is the opposite. These are values that we should have memorized, or you might draw triangles to figure those out. I'm just going to go ahead and fill in those values. So I have 1 plus radical 3 over 1 minus 1 times radical 3, or you might have just written 1 minus radical 3. I know I cannot have that radical in my denominator, so I'm going to have to multiply by the conjugate. Remember, the conjugate means that we have the same two terms, just the sign in between is different. So I'm multiplying by 1 plus root 3 over 1 plus root 3, and I'm going to FOIL this out. So once I FOIL that out, I can add my like terms together, so I get 4 plus 2 radical 3 in the numerator, and in the denominator I just get negative 2. So when I simplify, I get negative 2 minus radical 3, which is the exact same answer we got using the other method. So if we look at 15, I'm going to make this problem a lot easier by making it just 15 degrees, because I know 375 is more than 360, so if I subtract that, I end up with 15. Once again, I'm going to solve this using two different methods, so I'm going to start by using our half angle formula. So there's our half angle formula, and remember, this plus or minus depends on what quadrant this original angle is in. Since this original angle is in quadrant 1, and we know cosine is positive in quadrant 1, we know that this is going to be a positive answer. So I need to figure out how can I write 15 as something over 2, and I know that it is 30 over 2. So I just need to figure out what is cosine of 30 degrees. And most of you should know that off the top of your heads, that it is radical 3 over 2. Now my problem here is that all this is underneath this radical. So I need to go ahead and get another 2 under here. So I'm going to multiply by 2 over 2. So I get the square root of 2 plus root 3 over 4. When I square root the numerator, I get the square root of 2 plus root 3 over, when I square root 4, I just get 2. Now this answer looks strange, but that is the correct answer. Now we're going to go ahead and use our sum and difference to find cosine of 15 degrees. So we could use a few different angles. I chose to use 45 and 30, and so our sum and difference formula for cosine is cosine, cosine, sine, sine, and I know this sine is going to be opposite. I kind of ran out of room over there, but I think you can read sine of 45, sine of 30. So now I'm just going to substitute in those values. So I have root 2 over 2 times root 3, which is root 6 over 4. And my other fraction, root 2 times 1 is root 2, and 2 times 2 is 4. So I get root 6 plus root 2 over 4. Now if you guys notice, this answer looks very different from what we found when we did half angle. However, they are equivalent answers, and on the test, either of those would be counted as correct. So if we look at 16, this is another problem where I could either use half or sum and difference. And what I noticed right away is this one's in radians, so I'm going to have to multiply by 180 over pi to change this. So I get sine of 195. Now if we think about 195, this is in quadrant 3, so that means that in quadrant 3, all students take, which means only tangent is positive, so sine is going to be negative. So that tells me this sine is going to be negative. So when I multiply 195 by 2, I get 390. Now, 390 is more than 360 degrees. It actually is exactly the same as 30. So I just went ahead and wrote 30 there, because I know this is in quadrant 1, and it's 30 degrees from the x-axis. We have our minus here because we know in quadrant 3 sine is negative. So I have the square root of 1 minus radical 3 over 2 divided by 2. I know to get rid of the radical in the denominator, I need another 2. So I get the square root of 2 minus root 3 over the square root of 4, which is 2. And I need to make sure to put my negative sign out in front. So if I'm going to use sum and difference, I chose to use 45 plus 150 because that adds up to 195, and those are both special angles. So I have sine, cosine, cosine, sine, and I know that my sine here needs to be the same as this one. I'm going to go ahead and draw out a triangle for 150 just so we can make sure we see where that comes from. So if we look at this triangle, I know sine and cosine of 45 is radical 2 over 2. But for cosine of 150, I have negative radical 3 over 2. And for sine of 150, I have 1 over 2. So I have negative radical 6 plus root 2 over 4, which is negative radical 6 plus radical 2 over 4. I can't simplify that any further, so that would be our final answer. Now, with these three problems on the test, if the directions say you can use either method, you guys can decide what you think is easiest and then just go ahead and show all of your work. Some problems will specifically tell you to use sum and difference, or it might specifically tell you to use half angle, so we do need to know how to use both of those methods. So now that I've gone through both ways on how to solve half angle and sum and difference, for these last three, I'm just going to use one single method. And if you guys use the other method, that is totally fine. And I think on the answer key, I probably have both answers. So for tan of 75, I'm actually going to use the half angle formula. So I made this into 150 over 2, and I went ahead and applied the 1 minus cosine over sine formula. So now I'm going to draw out the triangle just to remind myself what the values for 150 are. So I get 1 minus negative radical 3 over 2 divided by 1/2. This is very similar to the earlier tan problem we did, where I know dividing by 1/2 is like multiplying by 2. So 1 times 2 is 2. Radical 3 over 2 times 2 is positive radical 3. And if you guys use the other method using sum and difference, I probably would have used 30 and 45, you would get the same exact answer. So looking at 18, the first thing I'm going to do is multiply by 180 over pi. And something kind of strange is going to happen, because this is one where I am actually going to end up getting a decimal value. And I end up getting cosine of 22.5. And so if I look at a problem like this, I actually could not use our sum and difference formula, because there are not two special angles that add up to be a decimal. So I'm going to have to use my half angle formula here. So I end up getting cosine of 45 degrees over 2. So I have plus or minus the square root of 1 plus cosine of 45 over 2. And I don't know why my pen's going crazy there. But if we look at this, that's in quadrant 1. So cosine in quadrant 1 is positive. So our answer here is going to be positive. I know the cosine of 45 is radical 2 over 2. I'm going to have to multiply by 2 over 2 to get rid of our radical. So I end up getting 2 plus radical 2 over 2. And that is our final answer. We cannot do anything more with that. And our last problem, number 19, this is one, once again, because I see this 0.5, that I know I can only use my half angle on. So I'm going to make this 225 over 2. So plus or minus the square root of 1 minus cosine of 225 over 2. And right now I have plus or minus, but I need to think back to this angle. This is in quadrant 2. And if we think about all students take calculus in quadrant 2, sine is positive. So that means that our actual answer here is going to be positive. I know that cosine of 225 is in quadrant 3 and it's 45 degrees. So I drew out that triangle over here. I know the cosine would be negative 1, because that's the adjacent side, over radical 2, or negative 2 radical 2 over 2. So I am once again going to multiply by 2 over 2. So I get the square root of 2 plus radical 2 over radical 4, which is 2. So this is our final answer. So hopefully by viewing this video, you guys are feeling more confident going into this test. Just make sure you study your identities and formulas. Those should be very easy points at the beginning of the test for you. Make sure when you are doing all your work, we always need to be writing an angle after a trig function, even if it's just alpha or theta. And just kind of trust yourself. Keep working hard, and good luck on the test.